Hi, I'm Syed on Maths Online. Today we are going to discuss about the VTU model question paper number 2. Model question paper 2 2019-20, and it is CBCS scheme, and the subject code is 18MAT41. So it is question number 4B from the model question paper. Evaluate integral over C dz by z square minus of 4 over the curve C modulus of z plus 2 is equals to 1. So we know the Cauchy's integral formula. So we'll try to use the Cauchy's integral formula over here. So the Cauchy's integral formula is, so we know the Cauchy's integral formula, integral over C f of z by z minus of a into dz. Its value is 2 pi I into f of a. That is the Cauchy's integral formula. So it is not in the standard form of z minus of a. So you have to get that z square minus of 4 in terms of z minus of a. So to get in that form, we have to use the partial fraction method and try to eliminate that z square minus of 4 and express in the form of z minus of a. So consider 1 by z square minus of 4 is equals to, so you can further rewrite that as 1 by z square minus 4 can be written as 2 square. This is in the form of a square minus of b square form. So therefore you can write it in the form of a plus b into a minus of b, or z minus 2 into z plus 2. So a minus b into a plus b form it is. So we need to resolve this into partial fractions. So let us try to resolve this into partial fractions. Resolve into partial fraction. So we have 1 by z minus of 2 into z plus 2. That will be equals to, you can write it in the form of z minus 2. It is a linear term. You can write it as a by z minus of 2 plus b by z plus 2. So let us take the LCM. LCM over here is z minus of 2 into z plus 2. So just cross multiply that value. You will be getting a times of z plus 2 plus b times of z minus of 2. So our left hand side you can write it as it is. So the denominators will cancel out. So you will be left out with 1 is equals to a times of z plus 2 plus b times of z minus of 2. So now we need to find out the values of a and b. So put z to be equals to 2. So plus 2 minus 2 will cancel out. That second term will become 0. 1 will be equals to a times of z is 2 there. So 2 plus 2. Second term however will become 0. Okay, just ignore that one because it becomes 0 there. So 1 will be equals to 2 plus 2 will be 4. You will be getting 4a, or a will be equals to. So if you cross multiply that 4 on the other side, you will be getting the value of a to be equals to 1 by 4. So hence we got a as 1 by 4. Now to get the value of b, you have to put the value of z to be equals to minus 2. So minus 2 plus 2 will become 0 there for the first term. So put z as minus 2. So you get 1 is equals to, first term however will become 0 because minus 2 plus 2 will become 0. So the entire term will become 0. So that is 0 plus b times of Z value is minus 2, so minus 2 you get. So 1 is equals to minus 2 will be minus 4 B you got. Therefore the value of B will be equals to, cross multiply minus 4 on the other side, will be getting minus 1 by 4. So hence you got the value of B to be equals to minus 1 by 4. So we'll take that as equation number 1. So plug in the values of A and B back in equation number 1. So equation 1 implies 1 by Z minus of 2 into Z plus 2 will be equals to, so equation 1, A value is 1 by 4 into 1 by Z minus of 2. So A divided by Z minus 2. Then B you have, so B by Z plus 2. B value is minus 1 by 4 into 1 by Z plus 2. So you have got A by Z minus 2, B by Z plus 2. I plugged in the values of A and B there. So 1 by Z minus of 2, Z plus 2 can be written as Z square minus of 4, because initially I had taken Z square minus 4 to be equals to Z minus 2, Z plus 2. Right hand side you can retain as it is. So Z plus 2 can be written as minus of minus 2, so that you get in the standard form of 1 by Z minus of A. So now the expression is in the standard form. You can apply the integral over here. Integral dz by z square minus of 4, that will be equals to 1 by 4 outside. It is integral over dz by z minus of 2 minus 1 by 4 outside, integral of dz by z minus of minus 2. This is along the curve C. So we have to evaluate those two integrals. So a curve is given to us. The curve C is given, which is modulus of z plus 2 is equals to 1. That's the curve that is given to us. So what does that curve represents? So that curve actually represents the equation of a circle. The standard form of the equation of the circle is modulus of z minus a to be equals to r. So that represents the equation of the circle with center as a and radius as r. Here a represents the center, r is the radius. So I'll rewrite that as z plus can be written as minus of minus 2. That is equals to 1. So what does it represents? It represents a, z minus a. So the value of a is minus 2 there. And the point is written in the form of a comma 0, right? So that represents a comma 0. So minus 2 comma 0 will be getting, because a is the real term, you just get minus 2. On the right hand side 1 represents the radius r. So what does this represents? It represents the equation of a circle. It represents the equation of a circle. Equation of a circle with center as minus 2 comma 0 and radius is 1 and radius is 1. So let us draw the graph for this circle. So that represents the circle with center as minus 2 comma 0. Let me draw the x-axis. So the center over there is minus 2 comma 0, and that will represent the point minus 1 comma 0, and over there it will be the origin, which is nothing but the y-axis there. So you have x-axis and that is y-axis, and that represents the origin 0 comma 0. The reason why I have taken minus 1 comma 0 at the circumference, because you can see that minus 2 comma 0 is the center, and the radius which is there, radius is 1 there. So therefore the point minus 1 comma 0 is taken on the circumference, so that will give us the radius as 1. Therefore we have taken the point as minus 1 comma 0. So you can see that represents the circle modulus of z plus 2 to be 1. with the center as minus 2 comma 0 and radius to be equals to 1. Now we need to evaluate these two integrals. So let us try to check whether these two integrals, whether the value of a, the points lies inside the circle or outside the circle. So if it lies inside the circle, we are going to use the Cauchy's integral formula. So let me take that as equation number 2. So let us try to evaluate only that integral. 1 by 4 we will keep it as it is. Later on we will try to take that 1 by 4 value. So from equation number 2, so we have to evaluate the integral. Integral over c dz by z minus of 2. So here 2 is nothing but your value of a. So z minus a form. So you got z as a value is what? 2. So 2 is nothing but your coordinate value, that is 2 comma 0 will be the coordinate. Reason why I have written is 2 plus I times of 0. So 2 represents your x coordinate, 0 will be your y coordinate. So 2 comma 0 you got. So where does the 2 comma 0 lies on the figure? So 2 comma 0 will be on the positive x axis. So that you can take it as say 1 comma 0. That will be 2 comma 0. So that is the point which lies outside the circle. So since the point lies outside the given circle, from Cauchy's theorem the value of the integral will be 0. So this circle is there. So outside the circle the point is there. So therefore from the Cauchy's theorem you can say that the value of the integral will be equals to 0. Therefore let me write down the integral value. The integral value will become equals to 0. So since the point 2 comma 0 lies outside the circle, modulus of z plus 2 to be equals to 1 is the circle we have. So modulus of z plus 2 is equals to 1. Therefore from Cauchy's theorem, so that integral value, integral over c dz by z minus of 2 will be equals to 0. So hence using the Cauchy's theorem we have shown that the value of the integral is 0. So let us take that as equation number 3. So from equation 2 we have proved that the value of the integral is 0. Now one more integral is there. So integral over c dz by z minus of 2. So we have to evaluate that integral also. So let us try to evaluate that integral. Again from equation number 2 we have integral over c dz by z minus of 2. So here a value is nothing but your minus 2. So you can write that point as minus 2 plus or minus I into 0. So that will give the point as minus 2 comma 0. So that minus 2 comma 0, where does it lie? But minus 2 comma 0 is nothing but the center of the circle itself. Therefore it lies inside the circle itself. Minus 2 comma 0 lies inside the circle. Because it lies inside the circle, therefore we can use the Cauchy's integral formula. Therefore minus 2 comma 0 lies inside the circle. Modulus of z plus 2 to be equals to 1. So therefore we will try to use the Cauchy's integral formula. Use Cauchy's integral formula. Integral over c f of z by z minus of a dz will be equals to 2 pi I into f of a. So that is the Cauchy's integral formula. So we have to evaluate for that particular integral using the Cauchy's integral formula. Therefore you have that integral over c, it is 1 by z minus of minus 2 times of dz, that will be equals to 2 pi I into f of a. Here if you try to see, the numerator f of z is not written, which means that f of z is 1 there. You can see f of z, in place of f of z you have 1, so we take f of z to be 1, and a value, in place of a you have minus 2, so therefore the value of a will be minus of 2. So let us try to calculate that f of a value. So in place of z, if I put it as a there, you get the value to be, f of a value is minus 2, so that value will be equals to, because f of z is 1, so right hand side will be 1 itself. Whatever value you take for z, it will be 1 only. So therefore if I try to just plug in back there in the expression, integral 1 by z minus minus 2 into dz is equals to 2 pi I into f of a. F of a value is minus of 2, but you know the value of f of minus 2, we have got it as how much? 1. So 2 pi I into 1 will be 2 pi I. That's the value of the integral. So let us take that as equation number 4. So let us try to plug in these two integrals, equation 3 as well as just now we have got equation number 4. You have to substitute back in equation number 2. So let us try to plug in equation number 2. So equation number 2 implies, so you have this equation number 2, both the integrals have been evaluated here. So you have to write down integral over c, you have dz by z square minus of 4 is equals to 1 by 4 as it is. The value of the integral is given by equation number 3. So its value you have evaluated, its value is how much? It is 0. Minus 1 by 4 as it is. Just now we have evaluated this integral. So what is the value of the integral we have evaluated is 2 pi I. Alright. So just plug in that value to be 2 pi I. So first term will be 0, you can just ignore that one, you can cancel out 2 times. So you get the value as minus pi I divided by 2. So that will be the required solution. So value of the integral dz by z square minus of 4 will be minus pi I by 2. So that's all I have for today. Thank you.